Hey there, welcome to this video. We are going to talk about simplifying quotients of radical expressions in this video. And we're looking at radical expressions where we have a fraction inside. Okay, so let's go ahead and check out some examples. So the first topic that I want to go ahead and talk about is rationalizing a denominator. And you need to say that word with me. Can you say rationalizing? Very good. Rationalizing a denominator. For an expression with the denominator to be in simplest form, the denominator must be an expression that doesn't involve any radical expression in any form. Plain and simple, mathematicians don't like having square roots in the denominator. So the math that must be done to complete this process involves multiplying the expression by a ratio of 1. I can manipulate mathematical expressions, but I have to do it within legal parameters. Okay, so here's an example of what we're going to be doing today. We have a square root of 1/3. And I want to go ahead and I want to remove the, I want to simplify this. Okay, so I'm going to go ahead and split my expression. So I have a square root of 1 over a square root of 3. And now I have that radical in the denominator. So what I have to do is I'm going to go ahead and in order to simplify or reduce the square root of 3, I'm going to multiply by a ratio of 1. And the ratio of 1 that I'm multiplying by is square root of 3 over square root of 3. And I'm being very, very deliberate in why I do that. And it's so that when I multiply a square root by itself, well, the square roots end up canceling, right? We get square root of 9, which is 3. Okay, so here is the simplified form. All right, so let's go ahead and look at some examples. We're asked to simplify each expression, assume that all of the variables are positive, and simplify numerical values as much as possible. So I'm going to go ahead and I'm just going to split my quotient. So I have the square root of 4 over the square root of x. And square root of 4, that happens to be 2. So I have 2 over the square root of x. Okay, so here's where we're going to go ahead and we're going to multiply by a ratio of 1. And I would write this down in your notes. Multiply by a ratio of 1, right? Because if I multiply something times 1, it's itself. I'm not really changing it, right? But I'm going to be kind of tricky here. I'm going to multiply by the square root of x over the square root of x. So you agree that the square root of x over the square root of x is 1, right? Anything divided by itself is 1. Okay, but I'm doing this for a reason. 2 times the square root of x gives me 2 root x, and the square root of x times the square root of x is the square root of x squared. But really, I mean, this step, I kind of want you to almost kind of get in the habit of understanding that when you multiply a radical times itself, the radical disappears, right? You're essentially doing an inverse operation. So we have 2 root x over x, and then there's your simplified form. Very straightforward. Let's go ahead and look at a different type of example. So here I have the square root of 5x over the over 2y. So, well, I'm going to simplify this to be the square root of 5x over the square root of 2y. And I don't have anything to simplify, so I can just go ahead and I can multiply by a ratio of 1. So what's the ratio of 1 I want to multiply by? Well, I want to simplify the denominator. So I'm just going to go ahead and I'm going to multiply by the ratio of 1, including the denominator. So square root of 2y over the square root of 2y. Okay, and in the last lesson, we talked about how we can multiply these. So I have the same radicand. I have 5 times 2. Well, that is 10. X times y is xy. Okay, over, and I have the square root of 2y times the square root of 2y. That's just going to be 2y. All right, and then that is your answer. Very, very simple. Okay, so I would like you to go ahead and try some examples. Here are some practice problems. Please go ahead, pause the video, try these, and check your work. All right. Okay, so hopefully you went ahead and tried these, and our answers for the square root of 24 over x is 2 root 6x over x. Okay, so 24 can be split as square root of 4 times the square root of 6. So that's how we get our 2 root 6. And of course, we want to simplify. We want to rationalize the denominator by multiplying by square root of x. Okay, in the next example, we have the square root of 3 over 4x. Well, that simplifies to be the square root of 3 over square root of 4x. The 4 can be simplified, right? That's 2. So we have square root of 3 over 2 root x. And then we're just going to multiply by the square root of x to rationalize that root. Okay, so the final answer would be square root of 3x over 2x. Okay, now we're going to go ahead and use the same idea, except this time we are working with cubic root expressions, okay? And it's important to understand that in order to simplify a cubic root, you have to have a perfect cube on the inside. So what we're going to be doing here is we're going to be looking for perfect cubes to simplify, okay? You have to keep that in mind. In order to undo a cubic root, you have to have a perfect cube. All right, so let's go ahead and same instructions, simplify each expression, assume the variables are positive, and simplify numerical values as much as possible. So I'm going to go ahead and simplify this. So this is the cubic root of 27 over the cubic root of x. And I'm just going to simplify the numerator. The cubic root of 27 is 3 over the cubic root of x. Okay, and I want to rationalize the denominator. Again, I want to undo a cubic root, so I need a perfect cube in there. So I'm going to go ahead and I'm again multiply by a ratio of 1. But what I'm going to multiply this time, I need to have a perfect cube on the inside. So I only have x the first. So in order to have an x cubed, like this situation up here, I have to introduce an x squared. Okay, and again, I'm using a cubic root, right? So the cubic root of x squared, that's what I'm multiplying by. Why are you doing this work? Well, let me go ahead and show you why. So the numerator, 3 times the cubic root of x squared over, well, now I have a cubic root of x times the cubic root of x squared. So that's the cubic root of x cubed. Oh, well, now I have a perfect cube inside a cubic root of x. So those cancel. And then our final answer, 3 times the cubic root of x squared over x. There's your answer. Okay. All right, second example here with cubic roots. I'm going to go ahead and again simplify. I like step 1 because it's very, very straightforward. It's just like, hey, we're going to go ahead and split up this cubic root. Okay, and I can go ahead and simplify here. I don't know if you see it. 16, that's the cubic root of 8 times 2. So this gives us cubic root, 2 times the cubic root of 2, right? Because cubic root of 8 is 2. All right, over the cubic root of x squared. Okay, so this time, pay attention here. In order to cancel out this cubic root, what do I need to introduce into the radicand to where it can cancel? Well, I have x squared, okay? So what do I need? Well, I just need one more x. I need to multiply by 1x into that radicand. So I have an x cubed. Okay, so I'm going to multiply by a cubic root of x. Okay, so what happens? We get 2 times the cubic root. Cubic root of 2 times cubic root of x is cubic root of 2x. And then I have the cubic root of x cubed, right? X squared times x gives us x cubed. Perfect, that's what I want, because now the cubic root cancels. So I have 2 times the cubic root of 2x all over x. All right, so let's go ahead and look at some practice problems. Here are some practice problems. Please go ahead and pause the video, try these, and then check your answers. All right, so hopefully you paused it. Here is the answers. So the cubic root of 24 over x, again, you can simplify out a cubic root of 8 in the numerator. So we have 2 cubic root of 3 over the cubic root of x. And what am I going to multiply a ratio of 1? Well, it has to be the cubic root of x squared. That's what needs to be in the radicand, is an x squared, right? So the denominator, we have a cubic root of x cubed to get rid of that radicand, again, or the radical symbol. The whole purpose is to get rid of the radical expression in the denominator. All right, for example 2, not much to simplify in the numerator, but you could simplify a 3 in the denominator. And then again, I just need to multiply by a cubic root of x so I can simplify the denominator. Okay, cubic root of 4x over 3x. All right, so those are some of the types of radical expressions involving quotients. Another type that you'll see and actually pretty consistently in calculus is with a expression that can be rationalized with a conjugate, okay? So I want to go ahead and talk about conjugates. This is another word also that we need to practice saying. Can you say it? Conjugate. Say it with me. Conjugate. Good. Okay, so what the heck is a conjugate? Well, conjugates are expressions with 2 terms in which the first 2 terms are the same, but the second terms are the opposite, okay? And so what you're going to do is you're going to look at this denominator. How do I rationalize this denominator? Well, you're going to multiply by the conjugate, okay, in a ratio of 1. So what would be the conjugate of 8 minus square root of 6? Well, again, it's the same 2 terms, 8 and square root of 6, except the sign changes. Instead of a minus, it's a plus. All right, well, how about for 3x plus 4? Again, the 2 terms are the same, 3x and a 4, except the sign changes. Instead of a positive, now it's a negative, okay? And here are 2 more. Negative 2x minus 5, its conjugate is negative 2x plus 5. Again, the same 2 terms, negative 2x, 5, except pay attention to the sign of the second term. It switches. And this also applies for imaginaries as well, as we have an imaginary example here, okay? All right, so let's go ahead and practice. So again, we're asked to simplify the expression, assume all variables are positive, and simplify numerical expressions as much as possible. So I have negative 2 over 3 plus square root of 11. I can't just multiply by square root of 11 over square root of 11 because I have a second term in the denominator, so that won't cancel out. So in order to go ahead, I'm going to multiply by a ratio of 1 involving the conjugate. Okay, so what is the conjugate? 3 square root of 11, and the second term is just going to change signs. So since it's a positive here, it's going to be a negative. So 3 minus square root of 11 is the conjugate. Okay, all right, and in the denominator we get negative 2 times 3, which is negative 6, right? We're distributing here. Maybe I want to write that out. Well, yeah, I'll go ahead and write it out, just so you understand. Okay, so then really this becomes a problem like the last lesson. You're just multiplying involving radicals. So we get negative 6 plus 2 root 11 all over 3 times 3 is 9. 3 times negative root 11 is negative 3 root 11. 11 times square root of 3 is a positive 3 root 11. And square root of 11 times square root of 11 is a negative 11. Okay, so why are we multiplying by the conjugate? Maybe you're asking that why. Like, how does this help us? Well, remember, our goal is to rationalize the denominator and to clear any radicals out of the denominator. So what we're doing is we're setting up a situation to where we have opposite terms with these 2 binomials. So now the terms with the radicals end up canceling. So that's pretty cool. We get negative 6 plus 2 root 11 over 9 minus 11. That's negative 2. We can go ahead and simplify this. we get negative 6 over negative 2 plus 2 root 11 over negative 2. So that's 3. Looks like plus, and then the 2's reduce. Not plus. It's a minus, right? Positive 2 divided by negative 2. It's a minus, Schwarber. Root 11. So there's your answer. 3 minus the square root of 11. Okay. So let's go ahead and look at the next example. So same type of idea here. I'm going to go ahead and, in order to simplify this, to rationalize the denominator, I need to get rid of that radical. There's two terms, so I have to multiply by the conjugate. So I am going to multiply, well, the conjugate would be same two terms. So negative 6 square root of 2, except the sign in the middle switches, right? Or the sign of the second term switches. So plus root 2. So negative 6 plus root 2. Okay, and I'm just going to go ahead and distribute. So 10 times negative 6 is negative 60. 10 times positive root 2 is 10 root 2. And in the denominator, we get negative 6 times negative 6. Okay, that's positive 36. Negative 6 times positive root 2 is a negative 6 root 2. Negative root 2 times negative 6. Two negatives make a positive. And negative root 2 times positive root 2 is negative 2, right? Negative root 4, but we know. Okay, good. So, all right, how does this simplify? Well, we have negative 60 plus 10 root 2. And again, the whole purpose of this, right, is so that our middle two terms cancel, getting rid of the radicals. So that worked, right? They're opposites. Bye. It's my favorite thing to do. Just getting rid of them. 36 minus 2 is 34, and we can go ahead and divide each term by 34. Okay, and we can simplify. We'll just reduce by 2. So if I reduce by a factor of 2, this gives us negative 30 over 17. And then here, this would be a 5 over a 17. I just reduced by 2. So our final answer, negative 30 over 17 plus 5 root 2 over 17. All right, time for a practice problem. So here you go. Here is a practice problem. Please pause the video, give this one a go, and check your answers after. Okay, so hopefully you went ahead and paused the video. Here is the answer. So again, the conjugate would be 2 minus the square root of 5. Go ahead and distribute all your terms out, and you end up with 8 minus 4 root 5. Did you get it? Good job. Okay, here's another practice problem. Please pause this one. Give this one a go. All right, hopefully you pause the video. Here is the solution. So the conjugate would be 8 plus root 6. Okay, multiply both terms by that. And this one actually pretty tough to simplify and reduce. Well, I mean, you're reducing by 2. So hopefully you got it. Hopefully you saw that all the numbers were even and you could reduce by 2. Okay. And I have a typo here. I'm not sure why it went from root 6 to root 5. That should be a root 6 in there. So I'm glad I caught that error. Okay, so 6 root 6. All right. Now we're going to go ahead, same exact idea, except these examples just have more in the numerator. That's all they're doing. They're dialing up the heat by including more terms in the numerator. Okay, so again, we're going to multiply by the conjugate of the denominator. That's important. Conjugate of the denominator. I'll even write it up here. You should too. Conjugate of the denominator. Denominator. So we have 5 plus root 5. That's your conjugate. 5 plus root 5. Okay, so we get 2 times 5 is 10. 2 times positive root 5 would be plus 2 root 5. Negative root 5 times positive root 5 is a negative 5 root 5. And root 5 times root 5 is 5. Negative times positive is negative. So there we go. And in the denominator, we get 5 times 5, 25. 5 times positive root 5 is a positive 5 root 5. Negative root 5 times root 5 is negative 5 root 5. Whew, lots of 5s. And negative root 5 times positive root 5 is a negative 5. Okay, so let's just simplify and kind of clean up some terms. I have 10 take away 5. That's going to be 5. I have some terms here in the middle that I can combine. I have a positive 2 root 5 take away 5 root 5. I can combine those, right? Same radicand, same index. And then in the denominator, looks like 25 take away 5 will give us 20. And again, these terms cancel as designed, right? So those terms cancel. Okay, so let's kind of clean this up. So 10 minus 5 is 5, minus 3 root 5, all over, looks like 20. So again, I can go ahead and divide each term by the denominator. And it looks like only one of them cancels this time. I'm going to reduce by 5. That'll be 1/4. So 1/4 minus 3 root 5 over 20. That's your answer. Not too bad. Not too bad. We ask Ella that. Ella, do you like this? Not too bad. Not too bad. Okay. Here is a practice problem. Please go ahead, pause the video, and give this one a go. All right, hopefully you pause the video. Here is the solution. So the conjugate of one that you're multiplying by is the denominator. The conjugate of the denominator, I should say. So we will multiply by 8 minus root 3. Multiply everything out. Go ahead, combine like terms, and simplify. And you get 27 over 61 minus 11 root 3 over 61. All right. Hey, that is it for today. We went ahead and looked at radical expressions involving quotients, and specifically radicals in the denominator of a quotient. Okay, we have to rationalize the denominator. And don't forget that new fancy word you learned today, conjugate. Say it with me, conjugate. Good job. All right, catch you next time. Be safe, be easy. Peace.